again, and welcome to our final lesson of Unit 4. Today we're talking about direct variation. It is a final piece of our unit rate puzzle. What direct variation is you take our unit rate and you plug it into this nifty equation where we have the y-axis going up and the x-axis going over. If you take your unit rate times any of these x's, it will give you your y. So for instance, 2 times 65 gives you 130. 3 times 65 gives you 195, and 4 times 65 gives you 260. So it's kind of an input-output situation. You could also do it with a chart. So we're going to talk today about how to develop this equation and how to use it. Some vocab to go along here. Constant of variation is that number, 3. It's also known as the unit rate. We've talked about the the constant rate of change. We did that in unit lesson 7. It's just telling you what the change is. It goes up 2 for every 1, up 2 for every 1. This one will go up 3 for every 1 over. So let's take a look at this one. After 2 minutes, a diver enters the water. He has descended 52 feet. So let's make a table. Right, 2 minutes, that's the x. Right, usually almost always time is on the x-axis, 52 is the y. After 5 minutes, that's the next x, it's 130 feet. So what's the change in the y? 130 minus 52, I think it's 78, but let's just make sure. I can't type. 78. It's a change in 78. And 5 minus 2 is 3. So the change is 78. I wrote 72. Where the 2 came from, 78 over 3. If you divide that, you get 26. So it's a rate of change, or in this case, it's the constant of proportionality. It's the constant of variation. It's all the same basic thing, unit rate of 26 feet per minute is what they're diving at. Now, if you plug that into an equation, right, it would be y equals 26x. So let's take a look at it, one that's already kind of done for us. The distance traveled, y in miles, by the Chang family in x hours. So they tell us y is miles, x is hours, y equals 55x. So right in there, they show us the constant of proportionality. What's nice about direct variation, this equation, is it tells us the unit rate right away. We don't have to calculate anything. It's already in there. So I know it's 55. I know this family is driving 55 miles, y, over x, always. It's always y over x. Boom. See how easy that was to do? What does that represent? That represents their speed, how fast they're going. Now, how do we know if it's a direct variation or not? It's the same test as if it's a proportion or not. Does it make a straight line? Yes. Does it go through the origin? No. So in this case, this is not a direct variation. If it did go through the origin, it would be direct variation. I don't like this example because it's hard to graph decimals, so we're going to skip over here, and we're going to do this example. Now, down here, number 2. An airplane travels 780 miles in 4 hours. Make a table and graph to show the mileage for 2, 8, and 12 hours. Okay? We got 2 hours, 8 hours, 12 hours. So if it does 780 in 4 hours, we're going to divide that by 2 to get to 2. 4 divided by 2 is 2. 780 divided by 2 is 390. Now, if I double it, that gives me 8. Double it to get to 14, 15, 60. And once again, it's not perfect, but it's certainly better than the decimal. So at 2 hours, 390. At 8 hours, 1560. And at 12 hours, so in this case, I'm going to take that 2 times 6 is 12. 390 times 6 is 2,340. Which is right about there. Does that make a line? It looks close to a line to me. My graphing's close. Does it go through the origin? It has to, right? If you go 0 miles, obviously it goes 0 hours. So this is a proportion. I've just explained it verbally. If you have any questions, come online, go to email, Canvas, or see me in class. Do whatever it takes to dominate this lesson. Have a great day.